Okay, this is number 26 from the mock exam. This is what you were given, and then there's a whole bunch of questions asking about increasing and concavity, and increasing and decreasing have to do with the first derivative, and that's not going to help us at all. So what if we look at the second derivative and see if that leads us anywhere? Okay, and you can see by making this into the second derivative, you've now have the second fundamental theorem of calculus. So g double prime of x is actually just equal to e to the negative x squared. And that's because I'm taking this x and I'm putting it in with as a t. Okay, so e to the negative x squared is also equal to 1 over e to the x squared, just in case we need to look at it that way. Okay, so the first thing that we can eliminate is e, which says there's a point of inflection, because a point of inflection is when the second derivative is equal to 0. There's no value for x that could ever make this equal to 0, so here's your 5 choices. So therefore there cannot be a point of inflection. Okay, so we'll eliminate that as a possibility. Okay, also, if you look at 1 over e to the x squared, anything squared would always have to be positive. So therefore, 1 over e to the x squared is always going to be a positive number or greater than 0. Well, if the second derivative is greater than 0, then that means that the function must be concave up. So if you look at the choices, A says it's concave up, so that's good. B says it's concave down, take out B as a choice. C says it's concave up, so that's good. And D says it's concave down, so take that out. So at least now you have it down to 2 choices. Okay, and so now we are kind of stuck because A and C are talking about increasing and decreasing. So let's think about everything that we know about increasing and decreasing. I'm just going to erase a little bit of this to make some room. Okay, so we know that g is increasing if g prime is greater than 0, and g is decreasing if g prime is less than 0, okay? So what do we know about g prime? Well, I'm going to get rid of this. Okay, because we're interested in g prime, so I'm getting rid of all this g double prime guck over here. Okay, so you were given g prime. So think about this for a moment. It's an integral from e to x of 1 over e to the t squared dt. Right, I'm rewriting this piece here. It's a fraction. If you're going from 0 to x, that means all your numbers are going to be positive. So you're going to be putting positive values into the antiderivative. Well, if you have e to the t squared, that's always going to be positive. There's no way that the antiderivative is ever going to give you a negative value. So therefore, if it's always going to be a positive value, then g must be increasing. And that was choice A. Okay, so here's number 27, and you're supposed to be finding the second derivative. So you can easily find the first derivative just by dividing both sides by x plus 2y. Okay, and we find out that dy over dx is equal to this. Okay, so now to find the second derivative, we're going to need a quotient rule. So it's going to be the bottom times the derivative of the top. So for the derivative of the top, it's going to require implicit differentiation. So the derivative of 2x is 2, and the derivative of y is 1 dy dx. Okay, so we have the bottom times the derivative of the top minus the top times the derivative of the bottom. all over the bottom squared. Okay, so that is your second derivative, and you need to find it at the point 3, 0. So 3 is your x, and y is your 0. Okay, so we're just going to go in and substitute now. And so this x right here, I can now turn into a 3. And 2 times y, which would give me 0, because y is 0, so 2 times 0 is just 0. So 3 plus 0 is just 3. So I can take this whole thing out, change that to a 3. Okay. Then I have 2 minus dy dx. Now, dy dx is actually this thing right here. Okay, so I can put 3 in for x, and 2 times 3 becomes 6. Minus y, but y is just 0. So the whole numerator just becomes 6. Then I can replace this x down in the denominator with a 3, and 2 plus y is 2 times y is 2 times 0, which is just 0, and you end up with 6 over 3. So 6 over 3 is just equal to 2. So now I know that dy over dx is equal to 2. Okay, so then I can go in here and replace this dy over dx with 2. But 2 minus 2 is 0, and 0 times 3 is 0. So that actually eliminates this entire piece right here. Okay, and now I'm going to continue. So I have 2 times x minus y. So it's 2 times x minus y, but y is just 0. So 2 times 3 is 6. And then I have 1 plus 2 dy dx, but we just found that dy dx is equal to 2. So we have 2 times 2 is 4, 4 plus 1 is 5. And 6 times 5 is 30. So this whole numerator turns into a negative 30. Okay, let's look at the denominator. So I'll replace this x plus 2y, I think you're getting the hang of this now, with 3. And 3 squared is 9. And so the answer is negative 30 over 9, which is not a choice, but you can reduce this because numerator and denominator are both divisible by 3. So you'll get negative 10 over 3, and that was choice A. Okay, and this is the last multiple choice problem without a calculator. So you're being asked, given this function, what's the acceleration at a certain point? So the first thing we should do is find the acceleration. But before you can get to the acceleration, you have to do the velocity. Okay, and it's a positive sine t because the derivative of cosine is negative sine, so it's a negative negative. Okay, and then I'm going to find the acceleration. Okay, so here's my acceleration. It would be nice if that was the end of the story. But it's saying, what is the acceleration when the velocity is equal to 0? Okay, so here's our velocity, right here. And we want to set that equal to 0. Okay, and remember, you do not have a calculator. So the question is really, when is sine equal to cosine, but one of them is positive and one of them is negative? Okay, because I could have also brought the sine t over, the cosine t over, and that would have been negative. So the question is, when is sine and cosine the same, but one is positive, one's negative? Well, if you think about the unit circle, remember at 45 degrees, that's the only place where sine and cosine are the exact same. Okay, so what if I have 45 degrees here? Well, my x value is still positive. My x value is now negative, and my y value is now positive. Okay, so whatever this angle is, then that's the one that I want. So I'm really looking for the angle that would go here. So if half of the circle is 180, 180 minus 45 is 135 degrees. So here's what we know. That sine of 135 equals 1 over radical 2, and cosine of 135 equals negative 1 over radical 2. So they're definitely testing you on your unit circle on this problem. Okay, so when is sine and cosine equal to each other, but one of them is negative? And the answer is when t equals 135 degrees. Okay? So we have to put that into the acceleration, because it's saying what is the acceleration when t equals 135 degrees. Okay, so, but now that I have my little chart that I just made here, I'm all set. Okay, so I'll get a different color going. Okay, so I'm going to substitute 135 degrees. Alright, so I have a negative sine, oh, sorry, let me take that out. No, I'll keep that, sorry. Sine of 135 degrees plus cosine of 135 degrees. Okay, so here's my negative. Sine of 135 is right here, 1 over radical 2, plus cosine of 135 is right here, and negative 1 over radical 2. So a negative 1 over radical 2 and a negative 1 over radical 2 gives me a negative 2 over radical 2. And of course, that's not an answer because you're being asked to rationalize that denominator. Okay, so if we have negative, whoop, my whole screen just moved. Okay, so if you have negative 2 over radical 2, we rationalize by multiplying the numerator and denominator by radical 2. So we get this. And then those 2's cancel, and you're left with negative radical 2, and that was choice A.